So, first and foremost, is anyone else here doing the Watson Build Challenge? Raise your hand. Good stuff. Well, we've got some competition. Obviously not you. But we've got some competition in the room. So we're doing the Watson Build Challenge as well, because we genuinely believe that to be able to actually help our partners most effectively, we need to eat, or do you know what? I used to use the term eat your own dog food, but it's pretty disgusting. Someone gave me a much nicer one recently, drink your own champagne. So we are drinking our own champagne. We want to be able to help you guys to be able to do this in the real world, so therefore we are building our own systems. Anyway, AI. So it's really fascinating that Beth started the way she started, because the way she started was she basically said, so AI, you know, this is my personal definition. Now, if I went into Sam's security talk and said, give me your personal definition of a firewall, he'd go, I don't have to because it's incredibly well defined. The problem with this particular topic is it is still so incredibly abstract. Yet, Forrester, who are one of the most well-received and sort of well-respected organizations that do predictions in our particular field, have put a target of $1.2 trillion by 2020. Now, I used to do this 2020 thing. That's 1 year away, all right? So in 1 year, this will be a $1.2 trillion opportunity, right? So don't think because a partner that's sitting next to you or a partner that you meet is doing it already, there isn't an opportunity for you. But, and there's always a but, it is fantastically complicated. I appreciate you can't see it. I'm almost pleased you can't, because it reads horrendously and it's terrifying. There is so many different aspects, so many different rat holes you can get yourself down, so many different methodologies, algorithms, terms, and then we get into the mathematics of it. So this is one tiny little line for what we call a general adversarial neural network, right? Which is a pretty common piece of technology that you probably find on your iPhone these days. But that's how complicated it is. So the whole purpose of what we are trying to do, in conjunction with IBM, and you know, I run our global machine learning data practice, so I also look after our other vendors that we have in this space, but IBM very much have a very unique play in it, so bear with me. But the idea being that essentially we are hoping to try and demystify, bring a level of simplicity so that you can go and have conversations with your customers and explain exactly how they can take advantage of this. Now, what I'm going to do is I always find this really, really useful is I'm going to give a real-world example. This is based on an opportunity that we engaged in with a customer last year and genuinely drove business results. Now, for the purpose of this particular example, I'm going to call it Acme Dog Toys. They're the world's most advanced dog entertainment systems. But global sales have plateaued, and they need a new growth strategy. The first thing to understand when you go and engage in these opportunities is it doesn't have to be, okay, let's introduce it to do something completely brand new. It doesn't have to be, let's introduce it to do something completely abstract. The best way to introduce AI is to turn around and say, how do you do something today, and could I increase the efficiency of it by introducing a much more automated, much more accurate solution than having human beings do it or having someone sit there and troll through lots and lots and lots of something. I'm not going to give too much away because otherwise I'll give my lovely solution away. So anyway, Acme want to run a targeted social media campaign to discover leads. So the first thing they did was they targeted their salespeople and says, get on Twitter and search for dogs and find me people who own dogs that we can go and target with our ads to go and buy our new toys. So they went on social media, they searched dog, and this is what it came up with. A cage, a dog cage, but a cage, can't market to a cage. Someone speaking to a microphone, no idea what that came up as a dog. A dog GIF or emoji, which is once again utterly useless because I can't market to them. And a couple of pictures which maybe possibly correlate to people that actually own dogs. Not very useful. So they started trolling through, and they started basically printing off the leads and pinning them on a board. And this wasn't a million miles off of where they were. And that's actually my dog. And got to get your own dog in, right? But anyway, so this was horrendously tedious and horrendously manual. And they found 3 leads in a day, and it cost a whole human being's time. How could they do this more effectively? So the guy, so one of the salespeople attended Demystifying AI from Arrow, funny enough, and sat there and said, we have a problem that we think AI could fix. AI, we can use it to do visual recognition. So we could theoretically, if we got Twitter or Facebook and we basically passed it through, so we basically did that search for dogs, which pulled out every single mention of dogs, we put it through all the people in a particular geographic region or whatever, we basically funneled that massive load of junky data through an AI, could we then pop out all the people who own dogs, or all the pictures of people with their dogs, and all the dogs that look happy, and all the dogs that look looked after? Basically, people who are likely to buy our toys. To which we said, of course you could. But the next question was how? And this is essentially where I wanted to get to today. So we've got a real, non-technical problem that we need to solve. We want to increase, we want to find new ways to market. Okay, we want to discover new leads. One of the things that you'll notice from the previous slide is that none of the text in here actually mentions dog. Mentions my dog's name and some attributes about my dog. And actually, this is quite a common problem in this world. So, we are classic examples of people who buy loads of crap for our dog, and lo and behold, they're not going to market to us. So, we need to build a system. So any machine learning system comprises of 3 fundamental steps, right? We have to collect training data. In this particular case, the training data is as simple as pictures, but we need loads of pictures, right? We want pictures of dogs. We want pictures of people with their dogs, pictures of dogs from behind, dogs in beds, dogs on sofas, dogs in cars, right? We want the best possible training data set we can get. We then need to train. Once again, the complexities come back though, right? And then from that, we create what we call a model. A model is literally just a hyper-refined way of detecting dogs from pictures. So, how do we do this? First off, it's really important to understand that in the training phase, that's big data, right? We need as many pictures. The more pictures, the more accurate the pictures, the better the training data, the more accurate your model at the other end will be, right? The amount of refinement you can get from tuning and getting data scientists to do really expensive mathematics will be single-digit percentage increase. The percentage increase from having much more highly refined and bigger training data sets will be double-digit percentage increases in accuracy of your system. So the first thing to take away is you don't really need to know a lot about this. In fact, you don't really need to know anything about this to start in AI. You have to be able to help your customer to identify and tag good quality training data. That's domain expertise. That's not data science. That's understanding how to create a data set, not how to mathematically understand the sigmoid activation mechanism that you're going to use in the middle of your neural network. That's really important. Anyone here can go and help their customers tomorrow to start building a training data set. The next thing is 99 times out of 100, we black box that middle bit anyway. So it doesn't even matter. So actually, we turn that middle bit into a function where we literally go and collect the training data, feed it into the black box. In fact, often the model's also black box, and all we end up with is the output. IBM Watson is a great example of this. So IBM Watson is a hosted service. I won't go into it too much because John McNamara over there, a million times more clever man than I am, is going to take you through exactly how you can take advantage of this as a service. So all you need to do is put up your training data. It does all of this clever crunching for you. And then you just turn around and go, is this a dog? And it says yes or no. Really, really simple. Anyone can get into AI. If you want to do it slightly more in depth, if you want to develop lots of models, or you want to do something slightly more complex that needs to maybe break ever so slightly outside the black box, you can actually leverage, funny enough, a black box. This is the IBM AC922, which is their deep learning dedicated platform. Very, very powerful, built in combination with NVIDIA, and I won't go into too much detail about that because Beth's going to. So, moving on. Once you've actually built your models, it's also really, really important to understand that these platforms here are really only designed for building a model. Once you've built your Excel spreadsheet, you don't look at the formula and go, that's freaking awesome, right, I'm done. You then use that formula to make business decisions, to essentially start to calculate things. Well, at this end, these are some of the ways that we can actually deploy that model. And by the way, you can deploy it from Watson, you can deploy it from IBM Power to an iPhone. In fact, the iPhone has about 15 to 20 different AI models out of the box. So has anyone ever gone into their Photos app and opened it up recently on their iPhone or on Android? Instead of searching for, scrolling through your photographs, as I often do, next time you go in there, go in and type in the search, car. And your phone will have automatically gone through and recognized every single photograph in your phone without you having to put a single tag in. There's a picture of a car, or a beach, or a sofa, or dogs in cars. All right? Seriously, try it. It's really, really impressive. The way they do that is they train with terabytes and terabytes and terabytes in Apple of pictures of cars and pictures of beaches and pictures of everything else. They create these models and they deploy them to the iPhone. Terabytes of data to megabytes of data, running on those type of boxes, reducing it down to those sorts of ability to ways of actually deploying these models. But what I want you to take away from this is everyone can get started. This is really simple. Okay? So, Acme, let's go back to the use case. Acme essentially have developed a model. Next thing they want to do is they basically want to start to deploy a model to an inference server. Right? So inference servers are essentially what we've just said. They are either dedicated boxes, they are phones, they're anything where you can essentially start to deliver results. But I heard the term inference server the other day, and you know what? I didn't know what it meant. So I had to look it up. And I should know, because I've always called it predictions. Because essentially, all we're doing is using it to make a prediction. Because guess what machine learning does? Right? All machine learning does is just make a guess. Just very, very, very accurately. Right? There's no witchcraft or magic in machine learning. Essentially, what we're doing is we're taking this picture of my lovely dog, Rocky, we're turning him into what we call a tensor, which is essentially just a collection of numbers that say, this bit of him's this color, this bit of him this color, sort of that's the rough shape of him, he's got a tongue there, a nose there, we think that's probably an eye, that's probably an ear. You know, there's a high possibility that's a dog. And then it outputs this thing, but really all that means is, we're about 98% sure that's a dog. That's all we're doing in machine learning. And you can take this from a pretty daft idea like predicting about a dog, through to looking for sentiment in text, all the way through to detecting cancer in cells or images taken in laboratories. Okay? Because every single time all we're doing is using the computer to take all of the subjectivity out of us humans and become a very, very, very black and white guessing machine. But guessing incredibly accurately. Okay? Once again, the more training data you put in, the more accurate the guesses will be out at the other side. That's fundamentally all we're ever doing in AI. But obviously, when we get the dreaded cats in, sorry if there's any cat lovers in the room, but when we get the dreaded cats in, then obviously it can turn around and detect. So although it says, furry animal, 2 eyes, ooh, spiky ears. Very few dogs have spiky ears. But it could be a terrier, so we're about 25% positive that this is a dog, but actually we're 75% sure it isn't a dog. And that's all AI does. Whether you're using machine learning, whether you're using deep learning, whether you're using the umbrella term of AI, it doesn't matter. It does exactly the same thing every time. And that's essentially, I'm pretty sure, all I want to tell you about. So what did we do for this customer? So essentially we developed this machine learning network, we fed Twitter in, and Twitter started to basically pop out these leads that no one else had found. Because everyone else was looking for search terms. They were looking for dog, they were looking for owners, they were looking for, but they couldn't find people that would really love their dog and thought their dog were human and put names of their dogs rather than dog. And before you know it, global sales went up and we were launching new lines. So that's fundamentally the power of AI. It's incredibly simple once you boil it down. Once you get past people trying to make it really complicated and trying to give it these funky whiz-bang names and terms. Don't be drawn in by that. It is something that every single person in this room can go and have a conversation with their customer about. A, because I've just told you how simple it is to do, and B, because you've got the backing of Arrow and IBM to come and help you do it. Okay? As I said, we're drinking our own champagne. We've done this in the real world. We've been doing this for many years now. I don't know if any of you here remember a project that we ran a few years ago called How Happy is London? So How Happy is London was a grandioso scale machine learning project. And we did that 4 years ago to predict the real-time happiness of London. So, you know, we've done it. We understand it. We are your safety net. Beth is dedicated to be your safety net. I'm here. I have a team, global team. So, you know, we can help and we can move you forward. Last thing I want to talk about, one slide. Keywords, conversation openers, okay? Lots of people think they've got to go in and talk about AI. But as Beth said, there's positive and negative press around AI. Okay, so some of the terms that I've used to go and open conversations about AI, planning. How can we better plan? We can better plan if we can make better predictions of how we move forward. Automation, optimization, detection. We are using detection left, right, and center. Is just almost fundamentally AI now in factories and in sort of manufacturing. Determination. Let's try and determine something. Everything is just a classification, right? We're making a really good guess. Prediction and understanding. And with that, I'm done. Thank you very much. I'm here all day. Please, please, please come and talk to me. Thank you.